Welcome, Jane. Jane Hoffman is the author of the award-winning Backyard Scientist series of hands-on science books, science kits, and a teaching guide, all designed to make science easy and fun to teach and fun and exciting to learn. Jane is also a popular speaker at homeschool conventions, education conferences, and her audiences number in the thousands. Her teacher-in services are popular with school districts and private school associations throughout the United States. Jane, why is it important to teach science in the early formulative years?
Well, Sue, science is all around us, but most of us don't stop to explore it. Hands-on education should begin when your child is a preschooler. With many years of experience in science education, I actually feel I began my own son's science instruction 2 years late, but we made up for lost time, and my son is now an attorney. It is important to capture your child's interest in this important subject at the earliest developmental stage. Teaching science to your student, and we're always learning, so we're always students, will result in a more inquisitive child willing to explore new things and new thoughts. A child's mind is really primed to begin learning much before many of us think. Think of their brains as sponges, just ready to sop up information. 4- and 5-year-olds grasp things faster. Their minds are fresh and open that you can literally teach them anything. Science is definitely not beyond their understanding. A 3-year-old can pour vinegar and baking soda and see the result of that action. They are not being pushed into learning. They are merely learning by observing. This is the way critical thinking skills begin to develop. And youngsters in this age group need to be kept moving as their attention spans are shorter than that in older children. They need to be constantly moving, touching, and exploring. Hands-on science fills that need perfectly, all the while they learn and absorb information. This is also a perfect way for full-time homeschooling parents and part-time homeschooling parents to make learning fun and exciting and spend quality and enjoyable time with their children. It is amazing how much youngsters can learn by hand-on experimenting. Many prominent psychologists have stressed that beginning a hands-on science program first before teaching reading or math will result in the child being much more advanced later on in years in school. And there was a whole survey made where they taught kindergarten children just science, one class, and another class just reading and math. And they tracked these children until about the 4th grade. And at the 4th grade, the kindergarten class that did science was about a year to more ahead of the kids that did reading and math. So this really works. Also, exploring, mixing, and assembling also helps your child develop motor skills. Even if you are a part-time homeschooler concentrating on a hands-on science program at home, it will enhance what is taking place in the classroom without being redundant and boring. Few schools incorporate hands-on studies in the early years.
Well, I think some parents feel a little intimidated and feel like maybe they can't teach their children science in those early years. What would you say to that?
And that is so true. I was one of those parents years ago. Everyone is capable of teaching science to their young children. That is because they can learn basic concepts while having fun. You don't have to go into a great deal of depth at an early age. Just begin to expose them to the wonders of what things are and why things work or operate the way they do. Why is it light part of the day? Why is it dark the other part of the day? What is the difference between a sunrise and a sunset? Why do flowers bloom? There are so many things you can do on this subject with your children. What is the difference between a chemical and a physical change? And you can teach this right in the kitchen by using water, an ice cube, and by boiling water in a pot. Then you can compare that with baking cookies. The batter undergoes a chemical change when energy in the form of heat in the oven is applied to the cookie dough. Keep it simple, fun, informative, action-packed, and of course, use short time spans. You can always repeat the fun part. All it takes is a little planning and a little organizing. The rest is easy and loads of fun for child and parent. Another benefit of a home-based science program is that mom and dad will learn a lot about science too. Many of us, unfortunately, did not receive much science training when we were in school, or we elected not to take science because it was hard and boring. Now we can make up for lost time.
So you're able to see a lot of excitement just because you're looking for opportunities within the simple situations around your home.
Definitely.
So what is really the best way? Is there some specific thing that you could encourage parents to be doing to teach these young children a little bit about the science process and what's interesting in their world?
Well, the best and certainly the approach that is most exciting and fun is teaching science using a hands-on curriculum or just doing science experiments in a good hands-on science book. But select your sources very carefully. Be sure the experiments contain a hypothesis, a list of readily available and inexpensive supplies, complete instructions, and an explanation of what is taking place. This is the big why question. The key to learning is excitement. What is so exciting about hands-on science is that it provokes new ideas and thinking and additional questions. Actually, this is one of the most important results of a hands-on science program. The February 21st, 1991 issue of Newsweek magazine states that the science classroom, at least through middle school, should be a hands-on exploration of the universe. That textbooks that are daunting and boring should be burned. The article goes on to say that science can be learned and shared without jargon and complex mathematics.
Jane, can you give us some examples or tell us some things that the parents can do with their children?
I'm going to show you lots of exciting experiments that you can do with your boys and girls covering areas in physics, chemistry, and the life sciences. Sue, this is called the slime experiment. I would like you to touch it. This is one of the most popular experiments for kids of all ages, and they can't keep their hands off it. Of course, touching, smelling, feeling, and using our other senses is an important part of observing. This particular slime is made up of a non-Newtonian molecule. That's a really big word, huh?
Yes.
But it's got a really simple meaning. The molecules in the slime, when they're under stress, like being handled, act like a solid. And when they're not under stress, they flow like a liquid. If you touch the slime, now touch the slime again, tell me if it's hot or cold.
Cold.
Okay, you will notice that it is very cool to the touch. That is because there is a chemical reaction taking place. All chemical reactions use or give off energy in the form of light, heat, or electricity. One of the chemicals used to make this slime is hot water. And yes, water is a chemical. The energy needed to produce the slime came from the heat stored in the hot water. This other slime that you will see on the film clip is called cornstarch. And this is also a form of slime. It's a really fun experiment. While the two slimes exhibit some similar properties, they are very different in composition. The one we just saw, this particular slime, was produced by a chemical reaction. The other, in the film clip, is merely a chemical mixture. The atoms and molecules do not change. Boys and girls, through their process of experimentation, will observe the similarities and differences between these two slimes. And this is lots of fun for kids to do. Okay, well, this is actually cornstarch and green food coloring and water, just plain water from the tap. And Joel and Reese and Brian, what I want you to do is stick your fingers in there one at a time and kind of pound on it and tell me if it's hard.
Hard.
Okay, now pick it up very slowly and let it kind of flow from your hands. Pick it up, okay, and let it kind of, see how it's flowing like a liquid?
Yeah.
Yeah, that's because cornstarch molecules, did you know, they're flat just like a brick wall, and if you would have taken a car and ran it up a brick wall, what would happen to the brick wall? No, nothing would happen to the brick wall, would it? But what would happen to your car?
Boom.
The car would get all damaged because it would hit right against the brick wall, wouldn't it? But the brick wall would stay standing. This is a lot like the cornstarch molecules. When they're flat, the molecules line up like a rigid form, and they're just like a brick wall, and you can pound on them. The harder you pound, they're all going to line up. But as soon as you pick them up, see how it gleams and globs like a liquid? That's because you're disturbing the molecule structure. And cornstarch molecules are known as a non-Newtonian molecule. That means that when they're hard and they're under stress, they're really, really hard. But when you pick them up and they're relaxed, they're not hard anymore, are they? Because they're not under stress. Now there are so many experiments that you can do with these. And I have a cornstarch kit that you make cornstarch in these. All these kind of experiments that you float them. You do all kinds of different things with them. Do you want to try it now? Yeah. Okay, why don't you take some and see what you can do with it. And you can make up your own experiments. What's fun about science is you're pounding it, aren't you? It's really hard, isn't it? Why don't you give some to Joel and let him play with some too. Let him take a little bit. You can each take some out. And it's fun to see what you guys, once you have experiments, you could just go on and do all kinds of things that you could think of. And you could observe what you are looking at, and you just drop it on the floor. And what happened when it dropped on the floor? It just kind of stood there, didn't it? And did you know that when you put it down and the cornstarch dries, it's hard right now, but it will just dry and flake, and you can just wipe it off, and it won't damage any surface. So parents that are out there don't have to worry about it being messy on the carpet because they're real dry, and you can vacuum it all up. Many of the experiments in my book suggest other ways of doing the same experiment using other things the children have around the house. The yeast experiment is a perfect example of this. As you can see, I have a small beverage bottle and an inflated balloon on it. Earlier, I added a small amount of sugar, water, but the water was warm, dry yeast to the bottle. This is the same yeast we use when we bake bread and cakes. It is what produces alcohol also. Yeast is a single-cell plant, and in order for yeast to grow, it requires moisture, heat, and food. It makes no food of its own. It does not require light to survive and can be dormant for long periods of time. If we look at the bottle, now look very closely at the bottle, you can see these little small bubbles, and kids love to look at these little small bubbles. This indicates that a chemical reaction is taking place. Here the yeast is converting the sugar and water into alcohol and carbon dioxide gas, CO2. The bubbles, the energy needed for this chemical comes from the heat stored in the warm water. It is the carbon dioxide gas that is inflating the balloon. Now this is a wonderful experiment to do for science fairs, especially when combined with some additional explorations. For example, your girls or boys may substitute the artificial sweeteners for the sugar or use molasses, or substitute fruit juices or other liquids for the water. Change the water temperature. Place a bottle in a brightly lit spot and another in a dark closet, and compare the results. Measure the balloon hourly to measure the rate of expansion. Record your observations on a chart. For children too young to write, this is where mom and dad comes in. Remember, only change one thing in each experiment, so otherwise you will not know what change caused the different results. And this experiment will fascinate your young scientists for hours and hours and hours. So in this clip, you will see several different experiments using dry ice. It is safe to experiment with dry ice as long as everyone wears gloves to protect their skin from touching the dry ice. And the experiment is always performed under the supervision of mom or dad. Dry ice is nearly 200 degrees below zero, very cold, and it will damage any skin it touches. You will find lots of experiments using dry ice in my Series 4 book. Here you will receive step-by-step experimenting instructions, necessary cautions, and of course everything you've ever wanted to know about dry ice, even where to find it. Dry ice is made up of carbon dioxide gas. This is the same gas we made with the yeast a moment ago. Raising its temperature does not cause it to melt like an ice cube. Dry ice is so much fun for kids to experiment with. The only precautions you have to take is you must wear gloves. Any kind of gloves. These are gardening gloves, because you don't want to come in contact with your skin and the dry ice. And you break up dry ice on a towel, and you dry ice at a dry ice plan. In my book, Series 4, it tells you all about dry ice, where to buy it, how to break it up, how to use it, and you take a hammer and you just cut it. Very easy. And now we're going to go on to the dry ice. And if you want more information about any of my experiments, you can all go to my website, which is www.backyardscientist.com. Now we've got 4 beakers here, and I've got dry ice already cut up into the beakers. We're going to take some hot water, and we're going to pour them into each container. And then we're going to call some kids over, and you're going to see how much fun they have with dry ice. Dry ice is just frozen carbon dioxide. That's all dry ice is. It's CO2. Look at that. Okay, where are my kids that are going to play with this? And all you're going to do is, don't put your hand inside the container, but you're just going to play with the top of it. Okay, here you go.
Just tap it?
Yep. And think about it. Is it cold? Is it hot?
It's cold.
It's cold, isn't it? That's because of the dry ice. Now, dry ice is completely different than ice. You know what happens to ice? If you put ice down, it will melt, right, and become water. Well, dry ice is frozen carbon dioxide, CO2, and it never goes into a liquid state. See? It is always sublimating. And what happens is when this all sublimates, it will just go away, and this will disappear. There won't be anything there. Can you all say sublimate? Sublimate. And it will all go away. So gas never turns into a liquid, does it? No. It goes from a solid to CO2, which is gas, which is carbon dioxide. Can you all say carbon dioxide? Carbon dioxide. So you never want to directly touch dry ice. That's why we always wear our gloves. What do you think is going to happen if I pour a drop of Dawn into this one?
I don't know. It's going to blow.
Okay, here we go. This is the fun part.
Oh, God.
Look at that. Looks like a steam engine.
Whoa!
Now you can pop the bubbles.
Oh, my gosh.
Pop the bubbles. Just take a big in your hand and squeeze it out. There you go. See all the steam? See all the gas coming out? Look at that. That looks like a steam engine, doesn't it? I took a balloon and opened it up. Had somebody open it for me. Nice big hole. And stuffed about 14 small slivers of dry ice chopped up inside the balloon. Now, after it's in the balloon, your kids can hold it. And this is great to line up a whole bunch of kids and have them hold the balloon and ask them what they think is going to happen, because as the dry ice sublimates, the balloon will get bigger because there is carbon dioxide in this balloon. And they can also play with it. Now, an interesting experiment to do is to get 3 balloons, one filled with dry ice, one filled with the air from you, just that you ordinary blow up, and try to get a helium balloon at the store. And take all 3 balloons, and you can see the difference is helium is lighter than air, carbon dioxide is heavier than air. So if you stand on a chair and you drop the carbon dioxide balloon and you drop the balloon with just the air in it, you will see that that is much lighter than the carbon dioxide balloon. And you can have races to see which drops to the ground first. This is called the film container experiment, and I have little dry ice that I've chopped up with a hammer in little teeny pieces. Now this is very important for an adult to do this experiment, preferably outside on a picnic table, and have the kids sit down away from it and watch it. This is a very exciting experiment. This is kind of like a rocket experiment, only much safer. Remember, parents must do this experiment with kids watching. I'm going to put a little piece of ice in each film container. And then I'm going to put the cap onto the film container and never use anything but a film container. And now I'm going to cap them. And we're going to stand back. This experiment takes a couple of minutes. The caps have to fit really tight. Everybody, do not take your eyes off the film containers. Okay? Woo! See, I get them to go way high up. Did that one go high up? Over the years, many full-time and part-time homeschooling parents have used the dry ice and slime experiments as the basis for science-oriented birthday parties. There are lots of other experiments that work well too. They are the talk of the neighborhood for months. A favorite of the children is taking home some of the slime in small cups or plastic eggs. Lots of fun, easy on the budget, and some learning at the same time, and that really works for me. I do a lot of teacher training for teachers in school districts throughout the nation. Many teachers write back to tell me that they have experiment days where classes will combine or the whole school will get together to do the dry ice experiments and the bubble experiments that we'll see in a moment. Science is contagious, but you will not get sick from it. It is fun when properly presented, and lots of learning takes place when hands-on tools are employed. Now, on this next film clip, you're going to see the biggest bubble you've ever seen. And frankly, this is a project for children 6 months to age 60 and beyond. Who does not like a big bubble? Guess what we're going to do today? Do you know that from 2 straws and string, and this is just light kite string, you can make a gigantic bubble? Did you know that? Did you know that? Did you all know that? Okay, I'm going to teach you how to make gigantic bubbles. Okay, you need 2 straws, and you take some light kite string, and you thread the string through the 2 straws, and then you knot it, and you got your frame. The bigger the frame, the bigger the bubble. The smaller the frame, the smaller the bubble. Okay, so we have all different size frames here. So we're going to see what kind of bubbles we get, okay? Now this is the secret to making good bubbles. We have our soap solution, which is Dawn, and bottled water and some glycerin, okay? Now we're going to take the 2 straws and we're going to put our string in the straws like this. We're going to put it together like this, and we're going to put it into our soap solution. And we're going to count to 10. Can we count to 10? Count to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now from now on you can just count to 10 to yourself real slowly. And then you take it out, and you still have and you let the excess of the bubble solution drip off, okay? So you've got your 2 straws. Now you carefully, it's a whole system to this. You take your 2 straws and you take your legs and you put them a little bit apart, and you can practice this. Put your 2 straws together and pretend that you have the bubble solution in, okay? And we slowly take our 2 straws apart, okay, until see the frame? Do you see the bubble solution in the frame? Yeah. And then you slowly bend down a little bit, and you kind of pull up, and it's very important to cross. At the end, you put your straws like to cross. Okay, now watch the bubbles, because you see the light in the bubble? That's the refraction of light. See all the little pretty colors in the bubble? Bubbles have a lot of chemistry in them. A lot of chemistry classes teach bubble as one of their experiments to explain chemistry and physics. Okay, let's pull it up. All the light you see. Oh, that was a big one. I gotta make one more big one. That was a gigantic one.
Get it ready, man.
All that is required is some cotton string, 2 soda straws, and a good soap mixture. And your children are on their way to learning about concepts in physics and chemistry like refraction of light, density, energy, molecular cohesion, and more. This project is guaranteed to excite every student, and they will never want to stop experimenting. You will, in this experiment, readily observe that students can have loads of fun while learning. They may not even realize that they are learning. This is what is so great about a hands-on approach to science.
Jane, could you tell us or show us some experiments, simple experiments on life science?
Yes, Sue. In my book on earthworms, there are loads of easy and fun-to-do experiments for boys and girls ages 3 to 12. Earthworms are fun to observe as they wiggle and they jiggle and they sometimes scrunch up. There are so many things your children will learn about these creatures and how important they are to our environment. For example, your young scientists will learn that earthworms respire rather than breathe air like we do. Another really fun experiment in the life sciences is butterflies. And you can send away for a butterfly garden from a company called Insect Lore. And they will send you the materials to get butterflies. And it is really neat to watch the butterflies because they are so pretty, they flutter around and they fly, and this is something we cannot do. The particular butterflies, and you can see some of them on the package because we don't have any real butterflies here with us today, but these beautiful butterflies are called painted lady butterflies, and they are one of the most beautiful butterflies in the world. And from this company, Insect Lore, you can also buy earthworms if you don't want to dig them up yourself. So you can get everything in the life sciences and have really fun experiments to do. Whether you are parents that homeschool on a full-time basis or a part-time basis, it is essential that you become totally involved in your son's or daughter's science education. Many of us that homeschool, as well as traditional school teachers, are far more comfortable teaching literature and social studies versus science. It is not hard to include a hands-on science program in your child's education. It is low cost, easy, and proven effective. Understanding basic science will become increasingly important in the next century. Why not begin preparing your students today?
Time seems to fly, oh, the years pass so quickly now, like sand through your fingers. You hold it once and then it's gone. The chill